Very good evening, students. Welcome to Jatadhara Educational Technology. And today we are just continuing with the polynomials that we did yesterday. All right. So hope you all are ready with your pen, your notebook, and if necessary, your textbook also. Right. Now let's move on to the first question. Our first question is the maximum. One second. Yeah, the maximum number of zeros that a polynomial of degree 3 can have is y square minus 3y plus 4 is a dash. Is it a linear polynomial? Is it a quadratic polynomial? Is it a cubic polynomial? Or is it a biquadratic polynomial? All right, let's see the answer. It is quadratic polynomial because it is in the form of quadratic equation only. Isn't it? Ax squared plus bx plus c is equal to 0. Right, see the next question. Sum and product of zeros of polynomial x square minus 3 are dash. Right, so what is sum over here? Let me use my pencil. I'm sorry, let me use my pen. So, sum is alpha plus beta, which is minus b by a. Isn't it? So, here the equation is x square minus 3, that is x square plus, once again, I'll erase it. X square plus 0x minus 3. So what is minus b by a? 0 by 1 is 0. What is alpha beta? Minus 3 by 1, which is minus 3. So your answer must be 0, minus 3. Right? That's how your answer is this. Now let's check how many of you are giving me the correct answers. Yes, I have Navatej who says option 2. You're right, Navatej. I have Satvika who is wishing me thank you. Good evening, Satvika, but I want the answer. I have Lavanya. Yes, who's giving me the right answer. I have Sai who says second option. Ashwita says third option. You have to check. I have Zara who says option 2. I have Ashwita who says option 2. All right, good. Now let's move on to the next question. Find the sum and product of the zeros of the polynomial, right? So here it is x square plus 0x minus 9. So what is sum? Sum is nothing but alpha plus beta, which is minus b by a. So here it is 0 by 1, 0 by anything is 0. And what is the product? Product is nothing but alpha beta, which is plus c by a. But here we have minus 9 by 1, which is minus 9. So it is 0, minus 9. All right. Yes. See the next question. Find the sum and the product of the zeros x square. So now write in this form, a square plus ax square plus bx. So 0x plus 9. Right? So what is sum? Sum is minus b by a. 0 by 1, which is 0. So this is alpha plus beta. Alpha beta is c by a. 9 by 1, which is 9. So your answer must be 0, 9. All right. Now let's see how many of you have given me the right answer for this. 0, 9. Yes, I have Satvika. Okay. I have Zara, Ashwita, Sai, Lavanya. Yes, Lavanya, you're absolutely right. I have Navatej. Yes, Navatej, you are also right, 0,9. Perfect. Yes. Next I have Ashwita, also says 0,9. All right, good students, but everybody must answer. Whoever is present over here, everybody must answer. Right, now let's move on to the next question. Find the sum and the product. We have x square plus 0x minus 25. So what is alpha plus beta? It is minus b by a, which is 0 by 1, which is 0. What is alpha beta? It is c by a, which is minus 25 by 1, which is minus 25. So it is 0, comma, minus 25. Okay, right. See the next question. If the zeros of a quadratic polynomial are equal in magnitude but opposite in sign, then dash. Product of its zeros is 0. Sum of its zeros is 0. There are no zeros of the polynomial, or one of the zero is 0. Right? So give me the answer for this. I repeat the question. If the zeros of a quadratic polynomial are equal in magnitude but opposite in sign, then product of its zeros is 0, sum of its 0 is 0, there are no zeros of the polynomial, or one of the zero is 0. You cannot take more than 1 minute, students. It's absolutely a theoretical question. So where you don't have to work out the sum, you just have to think over it about the quadratic polynomial. Right? So now let's see the answer. Sum of its zeros is 0. Right. Now see the next question. If one of the zeros of a quadratic polynomial ax square plus bx plus c is 0, then the other zero is dash. Right? So if one of the zeros of the quadratic polynomial ax square plus bx plus c is 0, then the other zero is dash. What is the other zero? Is it b by a, minus c by a, minus b by a, or 0? Is it clear? B by a, minus c by a, minus b by a, or is it 0? Yes, I'm getting answers from Lavanya. Okay. Sai, Ashwita, Zara. Zara says option 3. Ashwita says B. Lavanya says 2. Satvika says option 2. Yes, Ashwita says 2. Supriya says 9. Lavanya says 2. Navatej says option 2. I have Tejashree. Okay. Abdul. Okay. Then, and the last is Lavanya. Okay, right now. Mixed answer I'm getting. The answer is 3 minus b by a. Right, now see the next question. The polynomials whose zeros are minus 5 and 4 is dash. The polynomials whose zeros are minus 5 and 4. minus 5 and 4. Yes, can be option 2 or 1. All right. So it is option 1, right? Yes. See the next question. Okay. The number of zeros lying between minus 2 and 2 of the polynomial f of x whose graph is given below is dash. So the number of zeros lying between minus 2 and 2 of the polynomial f of x whose graph is given below is dash. Is it 3, 4, 2, 1? Think quickly and give the answer, students. So it has to lie between minus 2 and 2. So which means in the x-axis. Okay. Yes. It is 2. Because between minus 2 is minus 1 and 1. All right. Yes. See the next question. Among the following, which is not a polynomial? Among the following, which is not a polynomial? Think over it and then give me the answer, students. Option 1, 2, 3, and 4. Okay. So is it 1, 2, 3, or 4? Which is not a polynomial? Yes. It is option 4. X to the power 3 by 4 minus 7x plus 4. Right. Because power of variables must be integers, not fractions. Right. See the next question. If alpha and beta are the zeros of the polynomial f of x is equal to x squared plus px plus q, then a polynomial having 1 by alpha and 1 by beta as its zeros is dash. Okay. Then a polynomial having 1 by alpha and 1 by beta as its zeros is dash. Is it option 1, option 2, option 3, or 4? Now, by then, let's see how many of you have given me the correct answer. Yes, I have Tejashree Ashok who's joined, Navatej Gaud, Supriya, I have Ashwita who says option 4. Okay. Let's see. Abdul says x square plus x minus 20, the earlier question answer. I have Lavanya who says 1. Okay. Then I have Satvika who says option 2. I have option 3. Okay. Lavanya again option 1. Now option 2. Yeah. I have Satvika who says option 4. Again, I have Zara who says option 1. Okay, let's see how many. Yeah, I still haven't rolled down. Charan has given me many options. I have Tejashree who says option 4. Zara again option 1. Then I have Sahasrao option 4. All right, good. At least you all have tried. Good students. The answer is option 1. Qx square plus px plus 1. See the next question. If f of x is equal to ax square plus bx plus c, it has no real zeros and a plus b plus c is less than 0, then dash. I repeat the question. If f of x is ax square plus bx plus c, it has no real zeros and a plus b plus c is less than 0, then c is equal to 0, c is greater than 0, c is or none. Give your answers quickly, students. Option 1, c is 0. Option 2, c greater than 0. Option 3, c less than 0. Or 4 is none. Okay. Yes. Quickly. Let's see the answer. It is c is less than 0. Right. See the next question. If alpha, beta, gamma are the zeros of the polynomial, f of x is equal to ax cube plus bx square plus cx plus d, then 1 by alpha, 1 by beta plus 1 by gamma is equal to dash. Okay, what is 1 by alpha, 1 by beta, 1 by gamma? Is it b by a, minus b by a, or c by d, or minus c by d? Yes, quickly you can refer to the formulas that we discussed yesterday and give me the answer. Okay, your time is running. Quickly refer to the formulas and then give me the answers. Is it option 1, 2, 3, or 4? Okay, yes, let's see the answer. It is option 4, minus c by d. Right, now see the next question. If the product of zeros of the polynomial f of x is equal to ax cube minus 6x square plus 11x minus c is 4, then what is a? If the product of the zeros of the polynomial f of x is equal to ax cube minus 6x square plus 11x plus a. So if the product means what? C by a, isn't it? So minus 6 by a is equal to 4. So minus 6 by 4 means minus 3 by 2, isn't it? Right? It is, let's see how it has come. Product of the zeros means what? C by a. What is c by a? Minus 6 by product of the zeros. Yeah. By a is equal to 4. So it should be minus 6 by 4 is equal to a. So 2 3s are 6, 2 2s are 4. So it should be minus. That is your option 3. Because it is the product, isn't it? Okay, right. Now next question. If alpha comma beta are the zeros of the polynomial x square plus x plus 1, then what is 1 by alpha plus 1 by beta? Right? So what is 1 by alpha plus 1 by beta? Quickly think over and then give me your answer, students. If alpha comma beta are the zeros of the polynomial f of x is equal to x square plus x plus 1, then 1 by alpha plus 1 by beta. Okay. Yes, hope you would have got the answer. It is 2. Right. See the next question. The remainder when 2x cube minus 7x square minus 10x plus 24 is divided by 2x minus 3. The remainder, not the quotient. Okay. So what is it? The remainder when 2x cube minus 7x square minus 10x plus 4. 10x plus 24 is divided by 2x minus 3 is dash. One way is you can do the long, division method. Other way is you can make this 2x minus 3 is 0. So x will be 3 by 2. Right? So that you can substitute in this equation and if it is 0, then it means there is no remainder. Otherwise, you will have the remainder. That is the answer. This question was asked in the year 2009 in RJC exam. Yes, quickly give me the answer, students. Let's see the answer. It is 0. Right. Dash is a factor of 5 to the power 2n minus 1, where n is an element of n. Dash is a factor of 5 to the power 2n minus 1, where n is an element of n. Right? So, where n is an element of n, if you put n as 1, you get 5 to the 25 minus 1, 24. Right? Yes. Perfect. Okay. So you have to put the value of n as 1, which will give you 5 to the power 2 into 1, 5 square, which is 25, minus 1 is 24. This question was repeated in 2 years, one in 2006, the other one during 2008 in RJC. Okay. Now let's see how many of you have given the correct answers. Yes. I have Lavanya Abdul. Option 3. Then I have Satvika says option 3. I have Zara says option. I have Charan says option 4. And then I have Sai, who says second option, madam. Yeah, now third option. I have Zara again with option 3. I have Tejashri with option 3. And I have Sahasra with option 3. Okay. Yeah, Manogna option 3. Okay, Mani. Okay, he says I. Pranita God option 3. I have Abdul option 3, and then I have Supriya option 3. All right. Yes, good. Now move on to the next question. Ax square plus bx plus c is equal to 0 has its roots alpha and beta. Then alpha square plus beta square is dash. I repeat, ax square plus bx plus c is 0. It has its root alpha and beta. Then alpha square plus beta square is equal to dash. Is it the first option, or the second option, or the third one, or the fourth one? Yes, let's see the answers that is being pouring inside. Yes, I have Zara, who says option 3. Okay. Then I have Abdul, who says third option. Yeah, I have Charan, who says option 3. Zara again option 1. I have Ashwita, who says option 3. All right, good students. Let's move on to the answer. It is 1 by a square into b square minus 2ac. All right, now with this question, the last one we'll do now. After that, we'll have science. Right? Yes. Now let's look at the question. This question was asked in the year 2002 in RJC exam. Given that x minus 3 the whole square is a factor of x cube minus 4x square minus 3x plus 18. Its another factor is dash. Given that x minus 3 the whole square is a factor of x cube minus 4x square minus 3x plus 18, its another factor is dash. Is it x plus 2, x plus 3, x minus 2, x plus 6? X plus 2, x plus 3, x minus 2, x plus 6. Let's see the answer. It is x plus 2. All right, and how many of you have given the answers? Let's see. Yes, I have here, getting the names. Yeah, I have Charan. Option 1, correct. Zara, x plus 2, you're right. Okay, then Pranita says option 1, correct. So almost everyone, whoever has given me the answer has given me the correct answer. Okay. Yeah, I have Sahasra, who also says option 1. Good students. So you all really answered so well. And with this, we'll close for mathematics today. Right? So, okay. All right. So hope you all would have enjoyed your mathematics class. Hopefully we'll have accounts. I'm sorry. Hopefully we'll have our science. Sorry, by mistake, I said accounts. Over to you, sir.
Thank you, ma'am.
Yeah.
Hello, students. How are you doing? You're doing math so good. Chala baga chestunaru maths. So let's continue with physics today. Electric current. Let's solve some problems today. Problem solve JCs. We'll go for objective questions also. All right. Competitive exam pattern questions. All right. Let's see. Let's get started. So who do we have here? Good, good, good. Good evening, everyone. Sahasra, Ashwita, Charan. Who else do we have? Prasad, Divyanshi, Sanjana, Harshita, Pranita, Sahiti. Hi, hi, everyone. Manogna, Rakesh, Rushvita, Seema, Sai, Satvika, Supriya, Tejashree, Zara, Srikriti. Wonderful. So let's get started with electric current, students. So here we have the first concept, the flow of electric charge. What's electric current? Is the rate of flow of electric charge given by current is equal to charge by time. All right. Charge crossing a cross section in unit time is the current. Units ampere or capital A. When you write the ampere, you use small a. You cannot capitalize A there. When you use a small, just the letter A, you capitalize it. All right, look at this. Current in the conductor is due to the flow of electrons, but conventionally, we consider the direction opposite to the direction of flow of electrons as conventional current. So there are two kinds of current: electronic current, conventional current. Only one current flows, that's electronic current. But conventionally, we consider the direction of current to be opposite to the direction of flow of electrons. All right, that's conventional current. But what is actually happening is electrons are flowing. That's electronic current, right? And charge of an electron is 1.6 in 10 times 10 power minus 19 coulomb. Again, from that, charge is equal time times current. Let's see what's Ohm's law, right? This is a fundamental law on which all of the current electricity is based on. At constant temperature, the current in the conductor is directly proportional to the potential difference applied across the conductor. I think I've gone a little fast. I'll go slow. At constant temperature, the current in the conductor is directly proportional. Note, directly proportional to the potential difference applied across the conductor. So how to write it in this equation? V is proportional to I mathematically. All right, if I remove the proportionality sign there, I'll get a proportionality constant there, which is R. So V is equal to IR. It's fundamentally actually V is the cause, I is the effect. When a potential difference increases, the current increase out. That's the point, right? And R is the resistance of the conductor. Yes, someone has a doubt. Good, Ashwita. Good to see you like that. Good. Yes, Xiaomi M2103K191. What's the doubt you have got? Hello. And you can change your name. What's your name? All right, let's go forward with series and parallel. Resistors in series and parallel. All right. So when you've got a resistor, this is a resistor. All right. The symbol is the peak, and the symbol which you see over here is a symbol for a resistor. When you have two resistors, let's say the equivalent resistance in when they are connected in series is you just sum them up. R1 plus R2. All right. When they're connected in parallel, let's say there are only two, or in that case, you'll have 1 by R effective, that's R parallel, equivalent resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus, and so on. So number of resistors in parallel, you add their inverses and equate that to inverse of a equivalent resistance. That's the equation you use. Let's look at this one, students. We try chaining students, three resistors of 5, 10, and 15 ohms are connected in series. Find the equivalent resistance. So how do we do? Oh, I've got the answer already. Great. Charan, think again. Yeah, Tejasvi, good. Charan, yes, good. Pranita, think again. Charan, wonderful. Divyanshi, good. The hint is as well given there. Yes, Ashwita, good. So what am I basically doing? Because they're connected in series, all I have to do is sum them up. I've got, yes, Azra, excellent. I've got a resistor like this, another resistor like this, another resistor like this. So three resistors. This is 5 ohms, this is 10 ohms, and this is 15 ohms. It's not volts, Zara, it's ohms. But be careful, units are important. If you go wrong in units, everything is gone to toss. All right, be careful with units. So 5 plus 10 plus 15, which is 30 ohms, is my equivalent resistance in series. Yes, Pranita, excellent. All right. Now, let's go for the next question. Look at this. Here you'll have to use Ohm's law. A 12-volt battery, sorry. A 12-volt battery is connected across three resistors in series. 2 ohm, 3 ohm, and 5 ohm. Find the total current flowing through the circuit. First, find the equivalent resistance. Because they are connected in series, I just sum them up. And then I use Ohm's law. Hint is given here. So all we have to do is plug in the values. All right. So idea is given. All we have to do is calculation. Be careful, students. You are going wrong in addition. Be careful with that. It is both. Idea and calculation will give you the answer, not just one. You need both. Idea is important, but calculation is equally important. Idea is necessary, but not sufficient. Let me look at the answers. Okay. Aru is 1.2 amperes. Zara 1.2 amperes. Uh-huh. Ashwita, okay. Excellent. Good. Sasa, just think again. The formula is also given. V is equal to I times R. S. RS is 10. V is 12. I is 12 by 10. Yes, Sasra, good. Friend is excellent. Good. All right. So what am I basically doing? All right. Everyone has got it. So I think I'll still mention it. Equivalent resistances 10 ohms because they're connected in series. Potential difference is 12. 12 is equal to I times R, which is 10. So I is equal to 12 by 10, which is 1.2 amperes. Look at this one. 4 resistors are connected in series. Calculate the equivalent resistance. This is simple. I mean, there's no, the previous one was better than this. Not the ohms కూడా యూస్ చేసాం ఇక్కడ ఏం లేదు అలా. All you have to do is యాడ్ చేయాలి ఆన్సర్ ఇవ్వాలి అంతే 4 resistors కదా 8 plus 8 plus 8 plus 8 they're connected in series. Charan, it's not 2 plus 2 plus 2 plus 2. 8 అని ఇచ్చారు కదా 4 resistors of 8 ohms each. ఒకటి 8 ohms. See, comprehension is very important, students. Comprehension అంటే you have to understand the question by the as you read the question you should get the idea. ఇలా క్వశ్చన్ కంప్లీట్ చేసే వరకు ఐడియా వచ్చేయాలి మరి కంప్రిహెన్షన్ లెవెల్స్ అలా ఉండాలి బికాస్ ఎగ్జామ్ లో టైం ఉండదు కదా కాంపిటేటివ్ ఎగ్జామ్స్ కదా ఎస్ అశ్విత గుడ్ ఎస్ ప్రణీత చరణ్ థింక్ అగైన్ ఇట్ ఈస్ నాట్ what you've written 8 is each one each 4 resistors of 8 ohms each. Yes, Rakesh, good. So all I've got to do is yes, Zara, good, good, good. 8 plus 8 plus 8 plus 8, which is 4 times 8, 32. 32 ohms is the Effective series resistance. Yes, very good. Divyanshi, Zara, and who else? Sai, Rakesh, Ashwita, Pranita. Sharon, what's wrong? I think you got it. All right, wonderful. So let's go forward. In a series circuit, the total resistance is 60 ohms. If there are three equal resistors, what is the value of each resistor? Interesting. ఇంతకు ముందు రెసిస్టర్స్ ఇచ్చారు ఈక్వలెంట్ కనుక్కోమన్నారు ఇప్పుడు ఈక్వలెంట్ రెసిస్టెన్స్ ఇచ్చారు మనం ప్రతి రెసిస్టర్ కనుక్కోవాలి కండిషన్ ఏమి ఇచ్చారు ఇంకో అడిషనల్ కండిషన్ yes Rahul good you're the first one to answer Rahul excellent Sahasra is the second one to answer is there yes good Rahul Rakesh Sahasra excellent there are three equal resistors the condition additional condition based on which I can solve this is yes Charan excellent three equal resistors are so if each one is x 3x is equal to 60 x is equal to 20 ohms. That's it. And you've done it well. Look at this. A current of 2 ampere flows through three resistors in series. This is nice one. Find the voltage across each resistor. So I have to think of the potential drop or the voltage across each resistor as the current flows through resistor. Series లో కాబట్టి సేమ్ కరెంట్ ఫ్లో అవుతుంది అండ్ త్రీ ఆన్సర్స్ ఉంటాయి దీనికి he says find the voltage across each resistor అంటున్నారు you're not supposed to add మీరు టోటల్ పొటెన్షియల్ చెప్పకూడదు నాకు ఈచ్ రెసిస్టర్ అంటున్నారు అక్రాస్ R1 ఎంత ఉంటుంది అక్రాస్ R2 ఎంత ఉంటుంది అక్రాస్ R3 ఎంత ఉంటుంది నాట్ అక్రాస్ ద టోటల్ రెసిస్టెన్స్ నాట్ ద సప్లై వోల్టేజ్ ఎంత అక్రాస్ త్రీ రెసిస్టర్స్ ఎంత డ్రాప్ అవుతుంది అదే అడగట్లేదు అక్రాస్ ఈచ్ వన్ ఐమ్ సారీ మై థ్రోట్ ఇస్ లిటిల్ బ్యాడ్ ఐ హోప్ యు ఆర్ ఏబుల్ టు ఫాలో మై వాట్ ఐమ్ టాకింగ్ సో అక్రాస్ ఈచ్ రెసిస్టర్ అడుగుతున్నారు స్టూడెంట్స్ నాట్ all the resistors. So you'll have three answers here. Excellent, Aro. All right. He's already here with the answer. Very good. First one to answer and the correct answer. Very good. Pranita, again, I'm just telling you again that it is not one answer. I'll get three answers. Look at this. Look at the diagram I'm drawing. But one resistor has 4, another resistor has 6 ohms, another resistor has 10 ohms. Now current is flowing through each one because they're in series. ఎంత current flow అవుతుంది 2 amperes flow అవుతుంది now. I want potential drop across each one. I apply Ohm's law again. Current is 2 here. R is 4. So potential drop will be V is equal to yes. RS is 20, Charan, you're right. RS is 20, Charan. That's absolutely right. But we got to not find RS, but we got to find potential drop across each one. See, this is old, sorry. Let's use an eraser. V is equal to V1 is equal to 8 volts. V2 is equal to 12 volts. V3 is equal to 10 into 2, 20 volts. That's it. That's the answer. So Ashwita is correct. Aru is correct. Pranita, no. Sharon, have you got it? Pranita, have you got it? It is 4 ohms times 2 amperes current. Potential drop across the first resistor. Potential drop across the second resistor would be 6 into 2. Potential drop across the third resistor would be 10 into 2. Look at this one. Two resistors of 20 ohms and 30 ohms are connected in series across a 24-volt battery. Find the power dissipated in each resistor. We got to find power dissipated. So how do we do this? Yes. Yes, RS is pretty good, Sharon. That's the first step. Next, I'll find the current. Okay. Zaya's already got the answer. Good. How much is the current you've got? 24 by 50, right? Good, Zara. I'll just tell you the steps. Look, first I'll find out RS. Good, Ashrita. V by I. Sorry, RS I said, right? RS would be 20 plus 30, which is equal to 50. I would be V by RS 24 by 50, which is equal to 0.48, if I'm not wrong. Excellent, Abdul. Very good, Abdul. Now, once I get this amperes, all I do is I'll use this equation. I square R1. P1 is equal to I square R1. Yes, sir, and excellent. It's 0.48. P2 is equal to I square R2. That's it. All I got to do is substitute I here, R1 here, I here, R2 here. You get the answer. Yes, Rahul, Abdul, good. And who else? Sharon, Ashwita, Zara. How about this, Pranita? Sai, please go ahead. Seema, please attempt. That will give you confidence. It's not important that you should get correct. What is important is you should learn. Nothing wrong in going wrong, as I always tell that. But what is important is you correct yourself. Here is the next question. Three resistors in series have a total resistance of 45. If two of the resistors are 15 each, excellent, Pranita. If two of the resistors are 15 each, 15 ohms each, find the third resistor's value. Pretty simple. Three resistors in series have a total resistance of 45 ohms. If two of the resistors are 15 ohms each, find the third resistor's value. Sharon, look at that. It's there where you're going wrong, students. Comprehension. Two resistors are 15 ohms each under Naru. Abdul is absolutely right. Good. Pranita, your calculation could be wrong, but I appreciate your attempt. Nothing wrong in going wrong. Divyanshi, absolutely right. Yes, Ashwita, good. Why is it 15 as you all did? And also 15. Two resistors are 15 each. ఇలా నేను రెసిస్టర్స్ ఉన్నాయి 3 ఉన్నాయి. ఇది 15, ఇది 15, ఇది x అనుకోండి. టోటల్ ఎంత? 45. సో 30 ప్లస్ x is equal to 45. X, yes, good, Pranita. X is equal to 45 minus 30, which is 15. That's it. So comprehension is very important. This is the right time to develop that skill. By the time you complete the question, you should get the idea. What remains is calculation. Idea is not sufficient. It is just necessary. I mean, not just necessary. It is necessary, but not sufficient. But how should you get the idea? By the end, by the time you complete the question, you should get the idea, so that you don't waste time reading it again and again. All right, a 240-volt power supply is connected to 3 resistors in series. Find the total current in the circuit. Yes, Hazra, good. Charan, good. RS is 200. Abdul, absolutely right, Abdul. Very good. Abdul is the first one to answer. He has answered 2 questions very quickly and correctly. Good, Abdul. Abdul, you're doing good. Really good. Great. Great, actually. So what do we do here? Yes, Pranita, excellent. Yes, RS is 200. Ashwita, RS is 200. Absolutely right. Once you get RS, what do we do? He's asking for total current in the circuit. Find the total current in the circuit. He's not asking us RS. That's the intermediate step. మధ్యలో RS కావాలి మనకి. Right. So what do we do next? RS వచ్చాక. Yes, Pranita, good. Charan. You're using the formula wrong. అప్పుడు formula కూడా ఇచ్చారు చూడండి, Charan. You're not supposed to multiply V and R. You're supposed to divide them. V by R gives you I. 240 by 200, which is 1.2. All right, look at this. I've got a resistor. 3 resistors, 200 value వచ్చింది. V by R, 240 by 200 gives me R I, which is nothing but 1.2 amperes. That's it, pretty simple. How did I get the 200? Because he said they're in series. What are the series now values? 50 plus 70 plus 80, which is nothing but 200. Yes, Ashwita, good. Charan, good. Yeah, look at this. 2 resistors in series have a total resistance of 100 ohms. If one resistor is 60 ohms, find the other resistor. 2 resistors in series have total resistance of 100 ohms. If one resistor is excellent, Sahasra. If one resistor is of 60 ohms value, find the other resistor. Sahasra was the first one to answer in the quick. Was very quick. Sahasra, very good. Zara, good. You're doing it without the hint. Very good. Divyanshi, what have you done? Like, Divyanshi, what's your idea? I appreciate your attempt, but what have you done? Yes, Rahul, good. So look at this. I've got 100 is equal to 60 plus x. X is equal to 40. Here is where you've gone wrong. All right, I'll tell you. Yeah, Charan. So comprehension is what you have to build on. All right. So next class will, you focus on that comprehension at your end. మీరు కూడా comprehension practice చేయండి. Comprehension అంటే it's not English comprehension. What I mean by comprehension is two resistors in series have total resistance of 100 ohms. ఇది మనకి టూ రెసిస్టర్స్ ఉన్నాయి, రెండింటిని యాడ్ చేస్తే 100 వస్తుందని చెప్తున్నారు. అది అర్థమైపోయింది. నెక్స్ట్ ఏం చెప్తున్నారు? ఇఫ్ వన్ రెసిస్టర్ ఇస్ 60, ఫైండ్ ది అదర్. ఇంకొకటి x అనుకుంటే 60 plus x is 100. So by the time you read this whole question, you should get the idea what to do. Calculation తర్వాత చూసుకోవచ్చు. Yeah, Abdul, good. 5 resistors of 5 ohms each are connected in series. What is the total resistance? So this is the 10th question we have got. We'll continue tomorrow. In the next session, we've got objective questions next. This is the last question for today. Rakesh, Divyanshi, good, excellent Divyanshi. See, you've gone wrong before, but now you've got it absolutely right. Very good, Divyanshi. Divyanshi is the first one to answer. Divyanshi, Zara, Ashwita, Pranita. Ashwita, చూడండి 15 ఎలా వస్తుంది మనకి? 3 రెసిస్టర్స్ ఇవ్వలేదు, 5 రెసిస్టర్స్ ఇచ్చారు. ఒకటి 5 ఉంది. 5 plus 5 plus 5 plus 5 plus 5. All right, English comprehension also plays important role. All right. Yes, Charan, good. Abdul, good. Rahul, Pranita, Ashwita, now you got it. Divyanshi. Very good, Ashwita. I really appreciate. The way you are interacting, Ashwita, is really good. మీరు అక్కడే డౌట్ క్లారిఫై చేసుకుంటున్నారు. That's absolutely good. All right, so let's close for today. So, thank you, Ashwita. Thank you. And your interaction is really good. మీరు అక్కడే డౌట్ అడుగుతున్నారు, అక్కడే క్లారిఫై చేసుకుంటున్నారు, and you're correcting yourself. I tell you again, nothing wrong in going wrong. What is important is you correct yourself. All right. So let's get prepared for the competitive exams. This is just in training, not the test. మనం టెస్ట్ కోసం ప్రిపేర్ అవుతున్నాము. All right, students. So that's all for today. Good night and good luck.
Okay, students, thank you so much for joining. Let's meet in the next class. Thank you, Arun sir.
Thank you, ma'am.